looking at the DF to see if I've assigned it to DF and all the things are coming out properly. And then DF info, I'm just looking at how is the arrangement in terms of are there any now values, the data types, etc. And then I'm just looking for if there are any now values again. Then I'm now looking at the shape to see how many rows and columns do I have. Then from there, I then did a histogram of the graph of the data to see kuti distribution achakamira say maximum values and so on. So you would see kuti marital status we have 5 groups. It's already distinct 1, 2, 3, and 5. Gender tine 2, male and female.
Yeah, go ahead. Sorry about that.
Yearly income, some are going up to that's 150,000 and so on. And then our bike buyer, we need to either 0 or 1, either one buys a bike or the other one doesn't buy a bike. Then here I'm just looking at the density function, which is the probability density function of the individuals. This was just me being explorative to just see how these things actually are looking in terms of the density. So you would see the one for age would closely look like a normal distribution, but it has got some skewness. That is not normal. That is not normal. That is not normal. Etc. Now I'm choosing my X values. So I take all the values and leave out the bike buyer because we wanted to predict either one is going to buy a bike or not. Then that's what I did. Then I just wanted to check if for sure I have selected all the others and left the bike buyer, the column bike buyer, and it is evident from this one. Then from there I then did values because I now want the values. And then why I just took the buyer because this is what I want to predict. And then I did the values. Then from there I did a min-max scalar on X because if you look at going backwards to here, you would see that the values are ranging from 1 to 5, 1 to 2, up to per year is actually 150,000. So there's need for us to do a scaling so that we have scale in my chat. Then from there, what I then did here is after I have scaled, I put it back into X because I didn't want to use X scaled. So now my X values are now scaled like that. Then on line 19, I did the training and the test for X and Y. Then that is the shape for the train. That is the shape for the shape. Here I have a question. Why is it that we have 11 here? Maybe something that you would also want to discuss.
It gives you a tuple of rows and columns. So yes. That in your X, you have 14,787 rows and 11 columns.
Okay.
And in Y, you only have 1,400 and 14,787 elements.
Okay. And then now I'm now doing the model where I initialized it and then I used the ReLU, and then on the last output, I then used the sigmoid, and I used the 100 neurons, and then this is the summary of my model. Then from there, I then used the optimizer Adam, and then the loss I said binary cross entropy. And then from there, I used 300 epochs of batch size 20. And then that is the training that was happening. Then from there, I tried to draw the the loss, and also the validation. That's how it was coming out. So I don't know if this is the proper, is this the correct, I don't know. I'm still yet to find the, when you draw this graph, I just want to know, my second question would be, I just want to know what are the characteristics of these two lines, so that you then say my model is performing well. Then from there, I tried to do the accuracy against the validation, and it came out like that. And then that is my X test and my Y test. So I'm getting about 77%. And then that was the confusion matrix, where my precision is about 0.79 to predict not buying and 0.76 of buying. And the accuracy is 0.77. That's where I left it. I've tried to improve my model by tweaking these, by increasing the number of hidden layers, but it was actually falling. But then I increased the number of neurons. Then it started improving, and then one other thing that I was playing around with was the number of epochs. Yeah, I started off at 25, 50, 100, and it was improving. When I exceeded 200, then it started to sort of overfit, and then I went back again and reduced the number of hidden layers and did up to 300. That's when I started to have these kind of results. So when I read and looked for other ways of tweaking these to get more, to get a better performing model, I realized I should also consider increasing the percentage of the data that I'm using for training. So that is where I was now asking. Already I was using 20%. Where is it? I was using 20% here to train. 80% was used for training. Is that correct? Hello? Hello?
Yes, Tora, I can hear you. We can hear you.
Oh, okay. I thought I was
Yes,
gone there.
that's correct.
Okay. So
hello, can you hear me?
Yes.
Okay. Sorry, my network was acting up. Yes, Tora, that's correct. 80% is testing, and you used 20%. 80% was used on the training data set, and 20% for the test. Yeah, correct.
Okay. So now the other things that they were talking about is to increase the number, the percentage to increase the for training and then reduce our testing. And also they said I can increase the number of hidden layers and see how what happens. And also they said you can either use a different activation function. And then I looked for this. There's others which we did not cover, so I wasn't sure which one to pick. So I think this is where I left it. So now I think you can help me to improve this model.
Okay, yeah, that was a good job. So, before I help with the model, I think I should have everyone present, then we'll go over how we can tweak the models to perform better.
That's good. Okay. So I'll stop sharing.
All right. May we have our next volunteer? Come on, guys. Don't go to
Hello, can I try?
Okay, go ahead.
Okay, can you see my screen?
Yes, I can.
Yes. All right. So I started with important ones, and then I have the other ones which are at the bottom. Then I managed to read my data set bbc.csv, and then I had to check on the first 5 entries, including the columns. And then the shape as was done by the previous presenter. And then the info, this is just the same as before. And then on my EDA, I also plotted the histograms. And you can see the distribution of all the columns. And then I used the iLog slicing method. So I had to pick the first 11 columns for X, and my X came out that way. We can see the 9,000, which is representing the annual income. And then my Y was the bike buyers. And then I had to scale my using Minimax scale, because you find that the annual income was too high, so it was going to distort the model. So I did my data scaling the same as was done before, and I had to split my data into train and test. I maintained my X scaled and then Y, and the test size was 20%, and my random state was 50. Then my X train was now 14,787, and the test was 3.697. And then I went on to create my model. I was changing these the neurons as well, but I ended up at these layers. At the last, this was my last attempt, but I was just keeping increasing and decreasing them. And then my model, this was the model summary that I came up with after having those ones at 50. And then I compiled my model, and I had to fit the model. So the epochs, I started at 100, I did 300, I did 200. But when I was at 200, the lines down there on the graphs were actually diverging. The plot for the loss, and then for my accuracy, this is the graph that I came up with. But when I was at 200, these were actually distinct different lines. And then my confusion matrix on not buying, and 78 on buying as well. So this is what I came up with. Thank you.
Yeah, thank you for that. Another presenter? Come on, guys, come on. vari kumbozviita vari kuzvigona sei?
Sedhoni mati tiri kugonera.
Haamuri kugona. You see, once maipapo, it's now easier kuti takuziva tiri kutangira apa tichishanda nezvakati.
Hello, let me try.
All right.
Right. Yeah, I did exactly what Tao was doing, but that was a different approach. I don't know, maybe not ended well. Maybe I can just go through kuma graph pose. Laptop yangu haisina moto. Don't wait first of all. Like kuma graphs, I don't know the meaning of my lines. The loss and validation, then and the accuracy and validation. My lines, are they supposed to be close together or my lines are so different? Because what I did from Soro, everything is right. I did the same. But for assigning X, I have to drop some variables like the marital status, their house owner, and English education. The reason why not English, the education, the house owner, then marital status, haina effect yakanyanya to one day ku decision being made by the customer kuti anotenga here the bike or not. So I have to drop the English education, the house owner, and also the marital status. Then you understand what my graphs as no change. I don't know kaita. Then the graphs came up like this. After dropping those columns. So I don't know if it's any effect range of drop or maybe take out chance I taught the PCA based. I didn't attend the lecture my PCA. Because now not my columns doesn't affect the decision being made by the bike buyer. But otherwise all the procedures that one is the same. So on a different note, you wanted to ask, it's not any relation good drop, but these columns, I thought the decision being made by the buyer, the marital status, I effect and because already we have the total number of children. So maybe with the marital status, maybe these variables, it doesn't affect the decision being made by them. So I have to drop this. I don't know if it's not in the right or I just want to ask the question.
Tawand.
Yes.
Something. I think the decision to drop
On your fine tune.
Hello?
Or don't go ahead.
Because I've done the process right, but
when you're fine-tuning your model, usually most of the decisions accuracy yako yapi yamira sei?
Zvakaita tawo accuracy yangu was about 0.6, but when I dropped these columns, the accuracy changed to almost 0.74.
Yeah, so Tawan, another the decision from
PCA don't, but I didn't know the procedure and know what in the lesson PCA.
Oh, okay. Because now if you look at that in Damboisa PCA and ameno jaita uyangu and chaoni notebook randaisa ni PCA. Now not to marital status actually not to contribute more. Okay, if someone is married, it means that so it means that they are likely to buy a bicycle for an hour. So marital status you are drop and doing more foot no gonna kukanganzira was look you 97% accuracy. So Yago is actually performing poorly than mine.
Okay.
And also so I think it's in features which one do we have to drop? Because that not to power visa. Chongo chora chajo tombo tanga 0.6 and it. Then power visa mangwa boenda 0.7 something.
0.74.
So I think if we go and explore which one to remove, then it's gonna improve our foot. I don't know.
Because the other way and I gonna improve accuracy was for feature selection. So I think the method notions of PCA. Sakanda zongo drop zvangu arbitrary kuti ndingo later. But as you said, the marital status will contribute more. So I think I need to do PCA.
Yeah, sorry. I think so.
Okay, yeah, but are you aware kuti connections in normal machine learning algorithms? Yes, but kana tiri ku deep learning and Doka walked you through how it works ne kushansa feed forward and back propagation. So what it does is automatically inobhayati my features anenga singa contribute painonorowa back propagation papa anopedzira ne something like a 0 weight. Then if they have little information yacho inogona kutove chiverengwa mukati, which can account for that 0.74 and 0.77 difference.
Yeah, true. I remember.
So I guess it then depends ne model ya unengo uchishandisa. But anyway, yeah, that was a good attempt. Reka T1 vavangane so far 300. I guess I'll have one more. Then ndochitanga kugadzira one from scratch name muchindibatsira. Come on, guys, just one more. Antesetaite. Okay, ndongo kono nonga wane random. Okay, Christine Matani. May you present your solution?
Hi, John. Maybe Christina is prepared. I just wanted to ask, are we only bound to this way of doing things, or or there are also other things of doing this?
Well, at the moment, deep learning is the it thing, because my normal machine learning models are they have a plateau, they peak. With deep learning models, the more data you add, the better its accuracy. And the more complex the task, its performance is also notable. That's why my deep neural networks anozongoeditwa achizoshandiswa for various tasks. Case in point, when we're now doing with sentiment analysis net text, we're now looking at my recurrent neural networks, whereby it's similar to Amurkuitaya, but yetakuwedzera an LSTM layer, long short-term memory. And achitila time series takuzowedzera a gated recurrent unit, GRU, chidaro. So yes, you can go for IOA machine learning. However, to be truly competitive, kana uchizosangana nema complex task, there is a point at which ayo anomira and this one's work. So it would be in your best interest to familiarize yourself with both. If the task is not complex, if it's something very similar, we're not going for the normal one, who cannot decision tree. Even machine learning and something which is very simple, decision tree. As it becomes complex, wakushandisa ma-ensemble and boosting methods, wakuita random forest, wakushandisa gradient boost, chidaro. So this is at the moment in the industry, this is the epitome of well-performing models. But no, you are not bound to this. But I think in your PAMA project, part of the rubric can only be met if you use my deep neural network. Am I clear?
Sorry, Don, can you come again on that? What did you say?
I said, as I always say, there are many ways of killing a cat. And this is one of the ways. Actually, at the moment, usually deep neural networks, they outperform those shallow learning models in most instances. So your choice of model depends on the complexity of the task. However, Pamurukuita, your project, I believe part of the rubric can only be answered if you pursue these type of models, my deep neural network. They are easier. Attempting to satisfy all the rubric requirements becomes easier than machine learning. There are places where they fall short.
Okay, that's clear. I just wanted to, because I thought maybe a logistic regression was a best fit for this simple task.
Actually, I have had instances ekuti ndinotanga a logistic regression or a multinomial naive bias. Then I use that as the baseline, and I try to make my models improve them past my baseline akaset on AI. So what did you attempt with the logistic regression, and what accuracy did you get on that one?
It had poor accuracy, but much shorter. I think around 57, something like that.
Case in point. It's because pakasangana categorical variables and numeric variables. So logistic regression in my shortcomings, especially in such instances. But so Ndopa Banach where the shallow learning models end, my deep neural networks start. That's why we encourage the use of these models, especially as in complex tasks. Yeah. So who's presenting? Christine?
Hi, Don.
Hi.
I'm good. I had not managed to attempt as of now.
Koinda.
My TensorFlow had issues, remember that time, and I only managed to do that during the weekend. So yeah, I didn't attempt it as yet.
Okay. Anyone else who did not attempt the certain Dasarutsashe?
I had not managed to attempt.
And what's your excuse?
For me, I was traveling, so I couldn't really get access to my machine until today.
Okay. I'm sure I've said this a couple of times. So guys, this is just me volunteering. And unoza kuvolunteer kunonakidza uchiziva kuti uri kubatsira. Ende kubatsira kunobuda vanhu vachida kubatsirika. So if we're not moving together, then my efforts angu in trying to empower you guys with knowledge are in vain.
I don't.
And I
would want to try, but there is one thing that
Yes, Clement?
missed. There's one thing that I've missed on my coding. I didn't
what
scale. I didn't scale, but I can just share my screen. Then maybe you can correct me.
Okay, cool.
Okay, let me share my screen. This one. It's an error that I have noticed on my code. You can see my screen now.
Yes, it's visible.
Yes.
So what I did, the first line here, I've been importing all the libraries that I wanted to use. Then on the second one, I had to read my CSV file. Then for me to, from line 3, that's where I started my EDA, where I just selected the head of the data frame. And then here I was checking on the values that I've got now, values. And this line, I was describing the data frame. And then here I managed to plot the histograms so that I can get a pictorial view of my data set in terms of its the distributions of the values. Then from here, so this is where I was saying I missed it. I didn't scale. I think that's the error that I did, because it ended up giving me a test of a 50 something percent, but I think that's where I missed it for my module, maybe to reach something above 60 or 70%. Then on this line 7, I was determining my X and Y values using the ilog function. Then from here, from line 10, that's where I was splitting my data, X and Y, whereby the test size was 20% and then the train was 80%. Then the random state, I selected 44. So the shape of my X, the training data, yes, got 14,787 rows and columns. This is the shape of my X train. Well, this is where I was now creating my model. So I used activation function rel. Then I had 100 neurons, as you can see here. So I first started with 20 neurons and then with 3 hidden layers. But I don't know what was going on, or maybe is it because I didn't scale? I was just simply getting the same result. So I ended up using 100 neurons and then 2, 4, 6, 8 hidden layers. Then on the output layer, on the output here, I use a sigmoid activation function. Then here I was now compiling my model, where the loss function I use binary cross entropy, optimizer Adam, and then matrix I use accuracy. This is where I was now putting my model. Epochs of 100, then the base size of 20. These are the results. And if you check from let me see what I wanted to say. But my graphs now ended up being fine. I don't know what was going on. But maybe you may correct me in terms of where I could have got it wrong. Here is my model, where I was now checking the validation against the loss. Yeah. So at the end, I managed to evaluate my model, whereby I got a 0.69 in terms of accuracy, then 0.5 in terms of validation. Yeah, I think so.
So
maybe if you can.
When you validate a model, validate using the test.
Okay. All right. Okay, I get it. I'll correct that one.
Okay. Anyway, that's a good attempt. So, now we'll go through it together. We'll tackle this challenge together, right, guys? At least for those who made the effort, thank you.
Yes.
Sorry, Don, I've got a question.
Yeah, go ahead.
by tuning my hyperparameters up, is it always manual? Because I was trying to get my accuracy maybe to 80%, but the manual we try and error I was reading, and the time of course the maximum I could get was 79. So the other methods it's our boiling and then glitch search looks like the functions are
Yes, actually trikutozosvika patikuzokavha glitch search.
Oh, okay. So it's okay because
asi tichaitraya tichanisa tumaparameter tushoma nokuti mamwe emalaptop enyu akasvika kutopfungaira takanyatsoitraya tichiaplya moderately. It's very resource intensive.
Okay, thanks.
All right. Okay. Where is my screen? Okay, is my screen visible?
Yes. Yes, it is.
Okay. I should have done this earlier. I guess this would have made the task much faster. Dot model selection. Am I going to need any other library? Can I say yes? Okay. Delete our data set. Okay. We do our ETA. Okay. So what the histogram shows us can also be found here. Number of cars owned. Okay. That's nice. Okay. So yeah. Okay, marital status, gender, yearly income, total children, number of children at home, blah, blah, blah. Mhm. So my pair plot is taking long to draw. Richibula. I would want to do something.
Hi, Don.
Hi.
Can I just have a look on your libraries that you deposited?
The basic libraries you used. Yeah, done now. So it turns out the majority of our variables are categorical. Can you see this? So this is a pair plot. It shows the relationship. It shows the relationship between the various variables in our data frame. Okay. Takatotarisa takadai so. In the end, you would see which we only have 2 columns that tingati dziri nhingirekeni. Two columns that tingati dziri numeric. We have age and we have yearly income. Right. Mamwe SAI, they seem to be categorical. For instance, commute distance. Commute distance, at a glance, you would think could be so can you see even this is not continuous? Probably munangaganzi less than 1 etc. So what I would think in the end would be Atitore categorical variables asiri binary. Because the ones are binary, they are already 0 or 1. So we don't need it on them. So we're taking 1, 2, 3, 4, 5, 6, 7. Then yearly income achirotkaisia kadai. I want to drop Makola Matoda, which will be age, comma, bike buyer, gender.
I don't. Kindly increase your font.
Much better.
Much better. Thank you.
House owner flag. So you would notice as you are building your models, most of your time will be spent up.
Kushinga sadza riri kunaka ere.
Hatina kumbona nyama.
So
So, John, after what we have done, after the pay plot, how do we know that we still need to do more of ETA?
ETA. Usually after a pay plot, ndobva ndatotanga kupindira. This is marital status and what? House owner flag. No, and English education. In a positive relationship. Interesting. Well, it's not about ETA per se. It's about you discovering the distributions of your data. And once you now know how it's distributed, you then know what actions you should need to take in feature engineering.
Yeah, for example, like using the pay plot that we've just done, maybe it's because I'm failing to understand it.
The pay plot yakundibuditsira. If these were numeric, for instance, let's look for where is H, H, it's here. Can you see this? Then let's look for salary, yearly income. Can you see how it is? If they were numeric. Can you see what it shows us? These are all categorical. So based on this, ndakuda kuarova ngonechi one hot encoding. You don't get dummies. Yeah. Can we see what we now have here? Zero and ones.
Hi, Don.
Hi.
Kudzai kumusoro michana, chef.
I created a list of my columns. Dango exclude I. Doctor I asar. Cat. It consists of my columns and my categorical variables. So, what I then did was, I then encoded them. One hot encoding, such that marital status 200. Dai munhu yanga achi marital status yake, if it was 2 anenge ane 1, if it's not ane 0. If marital status is 3 anenge ane 1, if it's not anenge ane 0. Same for total children, etc. So I think I have covered the breadth of it all, except one. Iri kuda kukonzeresayo. Iri kuda kunetsa, which is gender. Min-max scalar, comma, label encoder. Work with this. Not the gender, it's 1 and 2. I prefer 0 and 1. No, my bad. Saka wakuona kuti except for house owner, except for yearly income and age, our data frame is now comprised of zeros and ones. Then L equals to min-max scalar okay, let me leave this here. Takutora our x equals to gf1 dot drop
nasara pakuona kuti one hoti coding yacho yaitwa sei
na pd.get dummies. Anyway, on this one, this one in Ruguzo upload tango. Bike buyer x is equals to G1 and dot values, right? Y equals to df1, what's its name? Bike buyer dot values. X scaled equals to scalar what define kumsoro kuya dot fit underscore transform So takatarisa x scaled. Uri kuona kuti macategorical edu anongoramba ari 0 or 1. Can anyone explain to me why that is?
Is it because min-max scale anongo it's a 0 and 1, so it doesn't change?
Exactly. Noti formula yake anenge achatoti if the value was 0, it will be 0. It will be x, which will be 0 minus minimum, which is 0, divided by max minus min.
1.
Saka 0 over 1 now it has 0. Then pana 1, it will be x, which will be 1 minus 0, divided by 1 minus 0. Saka nongo rovachi 1 over 1. So ndo panenge akanakira apo. So kana ta uku uyu wamutserendende. Kunye kuti I'm using a new machine apa ndo panenda kutorova macopy paste manje. I train comma by test equals to enter split x cubed comma y the size equals to what? 0.2. Zviri kuenderana. So because of one watching quoting, my column zangwa increase from 11 I'm going to 1 to 32. What equals to sequential. Hold on, I have to. Sorry about that. There was something I had to attend to. Rekashandini amkamchit. Chandani, how many epochs, guys?
100.
Okay, 300.
Maybe 100.
100 will do.
Yeah. Have a boss by default, it's 1. What should we go? So Yeah, at this point, we're experiencing some overfitting. Why bother? Why bother? Okay. So when we're creating a confusion matrix, we can use Seaborn convert the confusion. Right. Oh. Rikuoneka.
I don't, sorry to take you back. May you kindly scroll on the last line of the code?
Okay. Okay, let me do so just now. So 77 on our first attempt. This is the last line. I used the confusion matrix argument you normally used, converted it to a pandas data frame, then plotted a seaborne heat map. I put inside the heat map annotate equals to true so that it gives me the actual figures. So okay,
Just below the line written from SKLN matrix. Just want to follow the code.
All right. Come on. Okay, so I've uploaded the notebook inside the classroom.
Motion wapinda
Hi,
nevalence.
Don.
Switch off your mic.
Ndoda kutobvunza Don, network yachina inonetsa mani. Hi, Don. Hi. Sorry, ndanga ndichimboita challenge yekupinda panetwork apa. Pane pandaona pawanga uri kuchinja marelu, masigmoid nepadense. So ndokumbura hangu kutsanangura what exactly chate tichiita ipapo ende chinozoita kuti tizochuza paactivation kuti toisa relu kana kuti toisa sigmoid chii exactly.
Hello, Don.
Okay. Hello. Sorry. I had muted my mic.
Okay. My question to you was, how do you know? Okay, or why did you use one hot coding on the
On the
on
data
the,
set. Okay. Models normally assume that something with a higher value is a feature with a higher value is more important than a feature with a lower value. So if I have labeled data, it will assume that a 5 is more important than the 1. So when I then use one hot encoding, what I'll be now trying to accomplish is it's either it's a 0 or it's a 1. That's so the issue I'll be trying to eliminate. Are you answered?
yes.
Oh yeah, now I was saying that will be all for tonight. Tomorrow we'll be looking at multi-classification. So remember, it's important to practice. I have posted the notebook more Google Classroom. So have a lovely night. Are there any questions before I go?
Yeah, I see that after we have done the coding, the one-hot coding, the accuracy is still close to what we did without even doing that. And also we are concerned with maybe if you scroll up, right, on those two graphs, what exactly should we be looking out for? For example, are those two lines supposed to be on top of one another? Are they supposed to diverge? Are they supposed to converge? I don't get to understand why what happens to those ones.
Those two lines are supposed to show you an example. A concept called grid search, not grid search, early stopping or model checkpoint, whereby it monitors, okay, where is it? Okay. Currently, I no longer have my notebooks. Anyway, I'll just type it in manually. Okay, Saka. If I am to say, after we have compiled our model, Keras, Copex, I'll just put a 5 since it's an example. So let me start from getting our model. I want you to notice something. We still have our 100 epochs, right?
Mm-hmm.
Okay. Take a look at the validation accuracy. When it stops improving, the early stopping will kick in and cut the training process.
Okay.
In fact, let me do this. Below early stopping comma. Point. Can you see this? After only 26 epochs, model yedu yapva yatoti aiwa akana hakuna kwatiri kuenda. Can you see the lines are now closer? It did not allow them to diverge too much. Can you see this?
Yes.
It stopped after 26 epochs. Output check. Model checkpoint. Okay. H5. I'll be saving the model in an HDF5 formula. Monitor. I'll go for and then in what would type. Take this to be true, then suppose equals to 1. So going through the same process again. Early and the check. I want you to see the difference in Obudai. What's the saying?
Saving model to bike.
So whenever the model improves, it saves. When it does not improve, it doesn't save. So in the end, Well, did not improve 5 times. So what happened? Yep, cut. So this is what it was monitoring. So those then avoid the issue of our model, our validation and train diverging, leaving us with, and it tries to leave us with the best model. So the patient's argument in early stopping, if it does not improve for how many epochs. So you can place it as 10 etc. It then depends on how many epochs you'll be running.
Sorry, Don. So patients 5, it means 5 times. If it doesn't improve 5 times, they need to stop.
Yes.
All right.
1, 2, 3, 4. Yapya improve. Then yakatangidza kuverenga 1. Improve. 1, 2, 3, 4, 5. Yapya stop.
All right.
So those are some of the techniques that go with overfitting. So guys, have a lovely night.
Sorry, Don, just one question. Just scroll up. Oh.
Chemwa.
Yes.
Before I know to book Saturday.
All right.
Hello, Tao.
Yes.
Ndoda zidasera sina kubvunza question yangu. Ndoda kubvunza pa create model wavo kuti pane architecture pana dense paper activation function tinokwanisa kusiyanisa here kuti pa first pakuenda first model toisa remu toenda futi layer toisa sigmoid kana tinokwanisa kuti vati vangoshandisa 1 then the output function yatinozosiyanisa ma activation function.
My thinking is you can use whatever you want. You would even notice kuti pane ndamborana ndichitoisa maneurons akatosiyana kuti nanchisa mufirst layer nanchisa kana kuti 100 next layer ndoisa 50 then the next layer ndoisa 100 ichidzi alternate. Hazvina kana pressure. Unozongozvionawo kuma results ako kuti is it improving or is it decreasing. Chero kashandisa ma different activation function because in each layer there are 2 things that is happening. There is your input function, which is your loss function, and your activation function. So you choose your to dash and such.
All right, it's okay, thanks.